For a geometric progression Bn, V subscript n, the sum of the first n terms is summation of equals to V1 into bracket 1 minus R raised power n over 1 minus R. R is not equals to 1, where R is the common ratio. So we are asked to show that S subscript 3n minus S subscript 2n over S subscript n is equals to R raised power 2n. So we have to show that if Sn could be equals to V1 into bracket 1 minus R raised power n over 1 minus R. Remember, or recall from that question we just squared, Vn is our last term of GP. Yes, our last term of GP. So Sn, if Sn will give us V1 into bracket 1 minus Rn over 1 minus R, that means S3n will give us V1 into bracket 1 minus R3n raised power 3n over 1 minus R. So what will happen to S2n? It will be equals to V1 into bracket 1 minus R2n. Are you getting that? So the 2 now, assuming there's 2 here, so here we'll be having like 2 here 2. You get that? And this is S2n, so we're going to be having like R2n2 there. So we can now proceed, and we should also note that V1 is equals to our first term. So we can now proceed to solve this now. What we're going to do in this question is that we make sure that we input this S2n or S3n minus this S2n over this Sn to be equals to R2n. So we have to prove this. We have to show them the proving that this is equals to R2n. So this my S2n, I'll substitute it for this S2. So this my S2n, I will substitute it for this S2n that is here, and S3n I showed you earlier, I will substitute it for this S3n here, and the Sn which was given us at the question exactly, I'll put it at this point here. So let me show you what I mean. The main goal now is to change this thing called S3n. So S3n minus S2n divided by Sn. Okay, so now I want to substitute them. Remember that S3n is V1 it is V1 into bracket 1 minus R3n over 1 minus R minus into bracket minus V1 into bracket 1 minus R2n, close the bracket, over 1 minus R. Now what we observe here is going to be divided by this Sn here, and Sn there is V1 into bracket 1 minus R raised power n over 1 minus R. Okay, so this one here, we move to this point here, and it will still be divided like it was here. So it will be divided by V1 into bracket 1 minus R raised power N raised power N divided by 1 minus R. Okay, in mathematics, if I want to change that division to multiplication, the denominator here, we have to go to the numerator, and the numerator here, we have to go to the denominator. So the way I don't want to use the word capside, the way change sides, change position. The denominator go to the numerator will come to the denominator. So here will become times. So let's write it. So it's going to be having something like times 1 minus R divided by V1 into bracket 1 minus R raised power N. Okay. With that, for this place here, we are having V1 into bracket 1 minus R raised power 3N over 1 minus R minus V1 into bracket 1 minus R raised power 2N divided by 1 minus R. What you observe that these two denominators are the same. So our LCM here will be 1 minus R. So 1 minus R divided by 1 minus R is going to give us 1 times whatever thing is here. So we are still going to be having V1 into bracket 1 minus R 3 raised power 3N minus, there's minus sign there. 1 minus R divided by 1 minus R is still the same thing. Going to have us V1 into bracket 1 minus R raised power 2N. Okay, let me clean this up so I will not confuse us here. Okay, times, remember that there's not times now, but let's just keep that times now. Let's work with this. Okay, let's continue times. We have, sorry, my board is not that big. Let me write it again so we can have something to look at better. Okay, times 1 minus R divided by V1 to bracket 1 minus R raised power 2N V1 to bracket 1 minus R raised power N, close the bracket. Okay, okay, so now this 1 minus R, this 1 minus R, what we observe that this and this, since it is multiplication, what will happen? They will cancel themselves, they are the same. Okay, so we'll be left with this V1 into bracket 1 minus R 3N minus V1 into bracket 1 minus R 2N over V1 into bracket 1 minus R N. Okay, so now what is common? We're going to open this bracket now. V1 will multiply through V1 times 1 will give us this V1 will times this one This v1 again will times this r3n that's inside this bracket. We're going to multiply it, we're going to times it. So this v1 minus v1 r raised to power 3n. Reason is v1 times 1 and v1 times minus r3n. That's going to give us minus v1 r3n minus v1 times 1 will give us v1. Now v1 times minus r2n will give us plus v1 r raised to power 2n divided by 1 minus now divided by v1 into bracket 1 minus r raised to power n, close the bracket. Okay, let's clean this. Okay, so now at this point here, because all of this is same as this. Okay, so this will cancel this because this is plus, this is minus. So v1 minus v1, that is 0. So we're left with minus v1 r raised to power 3n plus v1 r raised to power 2n. So if I commute this, I will have plus here, and here will be giving me 2 instead. So 2 instead of what we are having. So okay, and if I commute this will be giving me minus here. Okay, minus r3n. Okay, divided by v into bracket 1 minus r raised to power n. Okay, what I'm going to do next now is that let's clean this first. Okay, so what I'm going to do now is that I'm going to open this bracket here. This bracket, I'm going to open it. I'll write this back, v1 r raised to power 2n minus v1 r raised to power 3n divided by v times 1 is v minus v times minus rn, that is minus vrn, v raised to power r raised to power n. Okay, so having that, we can now move forward to the next step. Now I will look at this. What is common? What is common? V is common, v1 is common to the both sides, but I don't want to use v1 because I want it to look exactly like this denominator here. Okay, so what is common I can factor out or make it look like this denominator here. Okay, we have r2n, r raised to power 2n rather. R raised to power 2n, if I should factor out r raised to power 2n from this, mostly this point here, I'll be left with v1 as compared to here. Yes, v1, so remove. So, and here it is also v1, sorry for not putting that earlier. So v1, okay. So if I factor out v1, r raised to power 2n, I'll be left with v1 in this place. And if I factor out r raised to power 2n from here, I'll be left with v1 and the remaining 1 r raised to power n, because this is r raised to power 3n. So if I factor out r raised to power 2n, I'll be left with 1. So I'm going to write this now here. I'm going to have factor out r raised to power 2n, okay, into bracket. What I'm going to be left with is v1 minus v1 r raised to power n. Okay, now divided by v1 minus v1 r raised to power n. Okay, so now this is common, these two are common now. This denominator here and this numerator here, they are common, so I cancel it, so it cancel out, you get that? So I'll be left with r raised to power 2n. So I've proved that. I believe I've given you a Q hint and how to solve that question. So this is actually proved. Please don't mind my handwriting. We are working on getting a new board, so watch out. And if you are blessed, you can bless us. Link below. You can donate as fast as possible. And we are doing this with the love of finding you guys with solvings, new solvings, so that you guys would have we have more knowledge on your topics and your subject and pass it very well, and helps to build others also, so that other people too will also go from you. Okay, so thanks for that. We are moving to the next question. The next question says that